Okay, so let's get started with this problem. So, where c is a constant, how many different phase lines can you draw from this differential equation? So, we're going to test 3 different versions of c. First, we're going to test if c were to equal to 0, what happens? So, if c is equal to 0, dy over dt equals y squared plus 0, which is pretty much y squared. And if that's the case, then dy over dt is always going to be positive. Therefore, when we look at the phase line, it's always going to be positive, which is going to be a semi-stable point. Now, let's test when c is greater than 0. For instance, it could be c equals 1. So dy over dt is going to equal y squared plus 1. But because c is going to be a positive integer, dy over dt is always going to be greater than 0, meaning that we can't draw a phase line because there is no equilibrium points. So what if we tested a value where c is less than 0, such as -1? So dy over dt equals y squared minus 1. If you test this with any other negative integer, dy over dt can end up being I minus the square root of the constant multiplied by y plus the square root of the constant. So this gives us a phase line where it's going to look like this. And the values in between, when it's above the square root of the constant, is going to be positive. In between the two, it's going to be negative. But below the negative square root of the constant, it is going to be positive. Therefore, making this equilibrium point unstable, this point stable. Therefore, there are 3 different possibilities of equilibrium points. If c were to equal 0, there's one possible equilibrium point of a semi-stable. And if c were less than 0, it being a negative integer, there are 2 possible equilibrium points. Thank you.